In this video, we're going to go beyond model training and optimization and we go to a very important step of your machine learning project, deploying your model at scale. We will talk about TF Serving, TF Lite, and the Google Cloud Platform. So here we go. All right, well, let me first start with a very sad truth. Most machine learning models never get deployed. Maybe the outside world is too dangerous. Well, the reason is many of us develop machine learning model for our purpose of education. And for some of us, we were able to create a new idea to an app, create a model, but we never really finished it or we never really confident enough that the model succeeds. So we never really deploy our model, which is a shame. So I'm going to try to change all that. We're going to ask that everyone, if you have a great app idea, you need to deploy it out there. Let people use it, right? And part of the reason the model don't get deployed is that the deployments is used to be difficult, right? This is maybe one of your visual when it comes to deployment your model. I think they're very messy. But now that we have TensorFlow serving, things are getting a bit easier with the whole entire TensorFlow ecosystem. So how the TensorFlow serving will help us, right? So TensorFlow serving is a production-ready framework to serve ML model. And it is, part of the TensorFlow extended ecosystem. And it's well tested. It's used internally at Google. And also very hireable to serve large-scale model. It worked well for large model, up to 2 gigabyte. And, it's also check for new model versions to make sure you always on the latest model. So the first thing you do is you have to save your model. And then so far we work on machine learning. We do all kind of interesting things with our architecture, our training, our weight. So we need to save all of that into disk. And to save the model, you first have to specify, well, first you have to do all the training part, which is already been done. You specify the model version, the model's name, and a path basically join the model and the name. And then you call tf.savemodel.save, the model variable and the model path. So that would just save or export your model into file. And this is a consistent way for you to do model export. And the way it does is similar to what we actually talked about earlier is, in the course is that use the protobuf serialization protocol to save this model into a byte stream, right? So it's also save all the variable and checkpoints and having really nice, all the additional file into the same folder. So you look at the structure of the save model, it look like this, right? You have a save model's name, you have a version of it, you have some access, you have the save model in the protobuf type name, and you also have some variable, your data, your index, whatsoever. So it's everything saved in a consistent storage. Okay. So after you save your model, here what you're gonna have to do, you're gonna have to install the TensorFlow serving. And TensorFlow serving, it came in a format of Docker file. So first you have to install Docker. If you don't know what Docker is, you go on to the docker.com and find out more. Essentially Docker is just a de facto way to package and ship apps and software, right? So very useful in that regard, without going too much into it. But the first step, you install Docker, and then download TensorFlow serving Docker image, and then you can create a container to run this image, right? So the 3 steps you have is you have a Dockerfile, have a Docker image, and become Docker container. So, well, after you install Docker, you can just call Docker pool TensorFlow serving to download the Docker image, and then after that you call Docker run to create the Docker container for this image, right? So it looked like a lot of things you have to do here. I'm gonna go and explain hopefully each and every component here so you have a good idea, right? So this code create a Docker container, something like this. So container is basically a standardized container that kind of standardize your software usage, and you don't have to worry about that everything contained within one. And it's sort of, disregard to any machine configuration. It's trying to make things as standardized as possible, right? All right, so each component here, you have the -it. Basically, it's gonna provide interactive output for your container. -rm here to basically remove the container after you're done. And .p here is for your port, so 8500 to serve what called the Google Remote Protocol procedures, so the RPG call here, and also port 8501 is served with the RESTful API. More about that in a little bit. So this should allow you to get some query using the HTTP protocol. Okay. The next thing is to make the host directory available to the container, so the container would know what folder to go get your stuff. And then finally, also get your container, the environment variable at your model's name, or the container's names. So this way, the container would know what model to use for this container. And finally is the name of the image, which is TensorFlow serving, right? So this is basically kind of start a model server for you. In this case, we're going to do a local host. But still, this is going to start a server for you, and it will serve your model that you save in that folder, right? So that you can, and then you can use REST HTTP API to query this model and get prediction result and things like that. But this is how you can run your model there. Okay, so after you run this code, we need to query this server to get maybe some prediction or something from the model that you save. So the way you're gonna query it is with JSON, right? So you're gonna create a query with JSON, and think about it. Your query have to have two things. One is the signature name. Typically, you can set at serving default, and the other one is the data. So in this data, in this case, called instances, and you can sort of have it into some sort of a list, right? So if you had data at a array or an image or something, you can have it to list. So here's some example of what the input look like, right? You have a signature name, serving default, and the instant here, I think here they feed it in an image, so it's really long. So there are a lot of numbers here, but think about it. Think about serve it at your input data, right? And then after this is very important. You're gonna try to send this input data to the server and trying to get the result back using a HTTP post request. All right. So you import request. You have to know what is the server URL. In this case, we use localhost and the port number is 85.1 for REST API. You have your model version, your model, and then your model's name. And if you want to use prediction function, you say predicts here. Okay, and then you pack them all up, serve a URL, and then your data, your input data would be input data JSON, and you make a post request. And then you have to kind of wait for if any exception or error come back, and then you can stream everything into JSON format, right, into a variable response here. So this script is done in your in the code where you want to call your server to use the service. So, and then after that, you can the response basically just have one field called predictions, and you can turn it to a NumPy array, right, with the probabilities. And when you call that, what you get back here is just the confidence or the probability of a certain class of correct, right? In this case, I think this is for the MNIST data set. So you're gonna get back these confident, and then you can make prediction from there. So that's how you can load and query your model from your local host for now, right? But we're gonna do better, right? So if your app gonna be successful, you're gonna have a lot of different requests per minute per seconds here. So you will have to deploy TF serving on multiple servers and have a load balancer to make sure that you route all this query to the right TF serving server and be able to respond to that. Now, maintain, purchase, buying this server, maintain it, upgrade the hardware is probably not a good way to go. We're not gonna recommend you to set up your own machine, even though you can. It's just a lot of work, right? So instead, you're gonna use a virtual machine on a cloud platform. So you can use Amazon AWS, Microsoft Azure, Google Cloud Platform, the IBM Cloud, the Oracle Cloud, what have you. So these are gonna give you a lot of service in your hands, and you can do a lot with these very very strong services. Um, with that said, maintaining, managing all this virtual machine configuration, tuning, and monitoring could be somebody's full-time job. And in fact, there is class about all this cloud platform that you had to learn. So I'm not gonna try to go to a lot of detail in there, but I'm gonna instead highlight some of the services provided by the Google Cloud Platform. And the reason we consider the Google Cloud Platform is that this is the only cloud platform that provide TPU computation. It supports TensorFlow, a model, and it also have really nice AI services like the AutoML Vision API and NLP API. So here is come the Google Cloud Platform. So first thing you had to do is you got to log into accounts, and you can use your Google account to log in. And then you can go to console.cloud.google.com to go to the cloud platform. And keep in mind, this service eventually will not be free. Google do charge money, just like AWS, Amazon, and other cloud platform. But you can start with free credits that you can request. And the resource in the Google Cloud Platform typically gather around a project. So it's project driven. And you also need some Google Cloud storage to store your model and other things. So this is what called a bucket. Okay, so you're going to do create different bucket to store your model amongst other data files. So what I'm going to do right now, I'm going to go into my own Google Cloud Platform. And you can see a lot of things in here. To be honest with you, I was hesitate to share this with you because a lot of things going on here. The project that you see here that I show you is the UVA landmark image dataset. So this is actually hosted on Google Cloud Platform. So you may be familiar with the previous lecture about this. Couple things you can look at is the resource I use for this project. I use 3 compute engines. So there is like 3 virtual machine learner running right now to host this project. And I also have, you're going to look at the virtual machines. Here it is. Well, here they are. So these are, just CPUs for now, and I use this kind of machines, and they have some of their own external IP address and so on. So, and I also have, and you can see the computing engine kind of compute right now using very small utilization of GPU. You can also looking at things like, how many requests the API actually use. So you can go to here, and let's just say that I click on just today. It will take a bit to render, but I can monitor sort of how my apps have been used and so on and so forth. So apparently what happened here is today it has some usage around 6 p.m. to 7 p.m. And I know that because I just, kind of test it out to see if it actually get used. So it actually have like 1 request per second pike here. So you can see that's something like that. You can also see like the buckets. So you see what file that you can store. So you can store like your model files and among other things. I'm going to show you like some of the file that we store on this bucket. So if you're familiar with the UVA landmark dataset, these are the data file for it. And so you're going to go into, kind of random folder up here and see what data is stored. So there's a lot of image file here. You want to be sure it's image. You can just preview one image here. So it is one of the image of our rotunda, right, stored as part of this dataset. Cool. All right, so that's essentially, one of the bucket that I store here. This bucket's actually quite large. They say the size here somewhere. No, it didn't say the size, but I think this was like 30 gigabytes that I store. Anyway, that is my Google Cloud Platform, and you certainly can see a lot more. Go back here so that you can see the dashboard. And if you must know, I do pay for this service. It's like so far $35 for this month. So for the computation and also to maintain the model as well. All right, so let's get back to our lectures here. So you log into your cloud platform. You will create a bucket to upload your server. You have to upload your model into it. So your save model, you're gonna create a model on the cloud platform and kind of point a bucket to it, so you know what file you need to use and what model to use and so on and so forth, right? So you also have to specify other details like what version this is, what the description, so on and so forth, right? And then after that, you can use a prediction service to query your server. And the Google Cloud Platform actually use TensorFlow serving, just like what I demonstrated earlier, but it's also take care of the encryption and the authentication for you, right? And the encryptions are based on SSL, TLS, and the authentication is token-based, so you need a private key to access this service. And yeah, your client code can authenticate to service account, represented by application, not the user. So you can set up the service account for different user as long as they requesting a same application. That's fine. All right, and this is very strict access, right? They only get access to the model to get exactly what they need and no more. Okay, so how do you write a script to query this prediction service, right? So you start with a authentication process. And if you register a account service for TensorFlow, you will get a private key. And typically you will set your private key. Well, this is actually not the key. This is maybe point to a file that have the keys in it. But you have to set it to environment Google application credential so that the cloud platform will recognize who you are. And then you're going to use Google API Client Discovery to build a resource object that wrap around this prediction service. So these are the code for it. You have to specify what the project ID is, what your model ID, and also model path. Typically it is project ID and model ID, and then you build the resource object around it. Right? And then after that, you're gonna write your custom predict function, and what this predict function does is take in the input file and dump it into a JSON file, and then making the request using the resource and then predict. And the predict need to know your model path and what is the data. And then you execute this request, and then wait for it, whether it has some network errors or something. So you have to, if you have some errors, and you raise the errors. Otherwise, you're gonna return the array, which is a prediction from the response. So many of these things feel like it's the same at your TensorFlow serving, right? You have a prediction in the response, and then you would return it into a NumPy array. Right? So you can call the NumPy array, and then you get that exactly same thing. But instead of running your local machine, now this thing's run on the Google Cloud Platform, which is pretty cool, right? So I know it's very fast to this, but next I'm gonna actually show you also how to deploy your app on mobile devices, right? So running on the server is one thing, but running it on at an app in your mobile device, it requires slightly different setup. So mobile device have some limitation in the ways that large model might take simply too much to load, use too much RAM and CPUs. So maybe your app on machine learning is very unresponsive. It might heat up your device, and it also drain the battery. So what do you do, right? So you can make it more mobile friendly, more lightweight, and efficient without dropping too much of the accuracy, right? So seems pretty daunting, but in fact, TensorFlow Lite is provide a lot of tool to help. It help reduce the model size. It helps reduce the computational need for the model to make prediction, and it also can adapt the model for specific device constraint. So that's Google TensorFlow Lite. So what it works is actually very straightforward. It will take the saved model that you saved early on disk and then compress it into a more lighter format. And they use what called the Platt buffers. So it's similar to protobuf. It's an efficient serializations library. And the way this flat buffer works is that it's trying to compress the model so that it can be loaded directly into RAM without any pre-processing. So it's trying to reduce some pre-processing and memory footprint. And the way you're going to do this is that you call TensorFlight, TF-Lite converter. From save model is a function, and you load in the path there where you save your model, and it will just, and then you call convert. It will do the rest for you, and the output is the TF-Lite extension, and that's it for your TensorFlight model. That's how you can load it into your mobile device and so on. So the other one way you can do it that you're trying to this word is hard. Quantizing your model weight down into a lower bit width. So typically we have 32-bit or 64-bit. You can try to reduce it to 16-bit or even 8-bit integer to make it, a less memory footprint. And the way it works is, trying to bend this model weight into, more quantized bits that more workable in memory. So there is a lot of detail into this. I'm simply to mention it, and you can certainly figure it out if you're interested in it, right? And the last thing I want to mention is, what about on the browser? What if, you're going to make your model live in the browser? And that certainly has some pros and cons into it. But the pro would be it can run directly on your user browsers, make your website more reliable, remove the need for a server or query to make predictions, and reduce latency because your model will live directly on the device instead of the server, so it makes it more responsive. And TensorFlow JS is a format that you really want and use to do this, and it's going to be a topic for our next video as well. So in summary, we to talk about several ways that you can deploy your model, right? So the first thing you have to do here is save your model on disk. So all that hard work you put in training, save on disk. And from there, you can deploy your model using TensorFlow serving, certainly on the cloud or on localhost. You can use TensorFlow Lite to deploy your model into Android, iOS, or who use this anymore, Raspberry Pi. You can use your TensorFlow JS to deploy it on the browser, and you can convert it and try into other language, but I find that this is less likely, right? So into our next video, we're talking about TensorFlow JS. But until then, take care.